So in this video, I'm going to be going over definite integrals. Now, the difference between definite integrals and indefinite integrals is that, okay, obviously you can see something new. It has a upper and lower limit, but I'll get into that now. But obviously, when we are integrating with indefinite integrals, we don't really have some type of value, right? Because normally when you're integrating, you think, oh, then what's the point of integrating? If you only looked at indefinite, then you're just going to get some antiderivative. That's basically what it is, right? But now we're working with upper and lower limits. Now I'm going to just write down in different colors that this is going to be the lower limit, and this over here would be the upper limit. Okay, that's really only the new things that we have in the integral that we are going to be dealing with in this video. Now it is raining outside, so I'm not going to be too loud. I just want to have the peaceful environment right now. But if you want to see how to take the antiderivative or to integrate, there's going to be a card that pops up right at the top. So you can just click on that if you want to see how to do normal integration. But now in this video, I'm going to be focusing on definite integrals. Okay. So now what do we note about this, right? Upper limit and lower limit, meaning, if we see the word limit, we can assume over here that, or not really assume, I don't like saying these kind of things, but we're going to actually be working with x values. So this is just x is equal to a, and this one is x is equal to b. So if we're trying to find the definite integral, let's just consider some type of function, right? So we have a Cartesian plane like this, and then we have another set of axes like this. And then we have a function, let's say it's a parabola, right? Like this. Well, actually, you know what? What I'm going to be doing is, okay, you know what? Fine. Let's just do that rather. Okay. Or you know what? Nah, a better starting point is using the cos square x graph. So it's going to look something like this, right? Something like this and then like this, right? Okay. So if we're trying to find the integral or the definite integrals, then we're basically trying to find the area under the graph, right? So we're trying to find, let's say, the area under this graph like this, right? But then before we can do that, we need to know our upper and lower limits. This would actually just be our lower limit, which is a, and this would be our upper limit, which is b, represented right here and here. Okay. So that is exactly what we're doing. But let's just take into consideration about the integrand, which is actually the function. The integrand is just f of x, right? It's what we are integrating. And this integrand is actually equal to, so actually no, let's take this into consideration, right? This can also be written as f, or capital letter f of x. Now, why am I writing capital letter f of x? What I want to quickly do over here at the bottom is just show you that if we're trying to find the antiderivative of f prime of x, this will just give us, or let's say the antiderivative of f prime of x is going to be equal to just f of x, right? Because it's the antiderivative, meaning that we are doing the opposite of taking the derivative. Okay, so that's exactly what's happening over here, right? We just normally notate it into a capital letter f of x. Some people actually do I of x, right? Or just I, because they mean it's the integral. But right now I want to focus on this instead, because most lecturers actually do that. So let me get rid of that now. Okay, so now let's continue here. If you remember how to integrate, right? So we are going to do the following. From the previous integration that we have done, it's going to look something like this. So I'm going to quickly just write this integrand into a certain formation. So just take note here. Okay, so let's look at this carefully. We have ax to the power of n with respect to dx. Okay, obviously with respect to x over here, meaning that we can integrate, where a is a constant and n is also a constant. That's what we're trying to say over here, right? Now, in order to integrate, we are going to say a multiplied by n, and then Oh, no, my apologies. It's not a times n. I just got the power rule mixed up over there. It's a times n, or a times x, sorry, raised to the power of n plus 1 divided by n plus 1. Guys, there's a lot of things that I have to remember at the same time. So I apologize. If I do say the wrong thing, I'll most probably like edit in the mistake that I've made. Otherwise, I'll pick it up immediately during the video. So yeah, just please note that not everything's going to be perfect here, but at the same time, I'm going to go over this. Okay, but now we have plus c, right? So that's how we normally do like indefinite integrals. Now, with indefinite integrals over here, or definite integrals, we don't normally include the c. Now, the reason why we don't include the c is the following, right? We're going to follow a new notation. So let's say that this is represented as f of x, right? And we know that capital letter f of x is going to be equal to this whole integral over here. Okay. So now how we are going to write this down is we're going to let this equal to capital letter f of b minus capital letter f of a. Now why are we doing this? Because initially we had f of x, right? Which was the integrand, which we had to take the integral of with respect to x. And now we get this answer, which is going to be capital letter f of x, which is the antiderivative of f of x. And that would also be equal to this over here, right? Okay. So now what's going to happen over here? If we do the following, if we say it's going to be f of b, right? So which means it's actually, this is going to be f of x, right? We know that this is equal to capital letter f of x. So we're just going to plug in these values here. So this is going to be a multiplied by, remember that b is being replaced with x now. So it's going to be a multiplied by b raised to the power of n plus 1 divided by n plus 1 plus c. And now I'm just going to write this a little bit to this side over here so I have more space. So I'm just going to do that. So this is going to be minus because we have the negative over here. And then this is just going to be written like this over here. Let's put the bracket here. So we're going to have a multiply. Maybe a is not the best one to use in this case. So I'm just going to be using m for now. Right? So m would actually be our constant. So let me just change this to m. And then obviously this would be m. Okay. So this will be m multiplied by a raised to the power of n plus 1 because we replaced x with a over here. Divided by n plus 1 plus c. Now, if you were to do this all the time when you are doing definite integrals, what you would notice is the following, right? This negative will go into both of these terms over here, meaning that this positive will become a negative and this positive will become a negative over here as well. So therefore we can write it like this. M into b raised to the power of n plus 1. Also, I do apologize for changing up the variables, but if you are paying attention still and keeping up, then I'm glad. So this is going to be plus c minus, then this will be m into a raised to the power of n plus 1 divided by n plus 1 minus c. And note how these can now cancel. This will always be the case, by the way. So that is why you don't have to write the plus c at the end whenever you're doing definite integrals. You will get a final answer or final value. Okay, so that's just like an introduction to definite integrals and how to actually go about doing it. And then obviously you plug in your b and a values. Okay, so which means, and then we found the area under the graph. That's basically what it's all about. Okay, so let's move on to examples to actually see how it works. Okay, so what I've done over here, on this side over here, I've actually written it down again. So this is the capital letter f of x is equal to the integral, the definite integral of f of x with respect to x, which is equal to capital letter f of b minus capital letter f of a. Meaning that this correlates to whatever we find as capital letter f of x. This is basically just the integral versions. that we're going to get. So you're going to see how that works now. So the first thing we need to do is we need to determine the integral of all of this before we do it. But we're going to have a different notation over here, right? We need to consider the numbers here, the upper and lower limits, right? These are going to be substituted into our x value once we find the integral. So this is how we're going to do it, right? So we're going to put a bracket here, and this is going to be the integral of 4x cubed with respect to x. It's just going to be, remember our form over here, it's going to be 4 x raised to the power of 3 plus 1 divided by 3 plus 1, right? And then outside over here, we're not going to say plus c, by the way. Remember, in the beginning of the video, I did tell you that previously I did tell you that the plus c's will eventually cancel. And I wouldn't recommend keeping the plus c in because it's just more work. If your teacher does tell you to keep it in, then I guess you must keep it in then. But right now, for this video's purpose, I'm going to leave it out because they're going to cancel eventually. We're going to put the upper limit here and the lower limit over here, basically, right? So that's our formation. That's how we're going to write it down. Okay, so we're just going to simplify even further. We're going to get 4x raised to the power of 4 divided by 4. And then the lower and upper limit outside like that. And then what we can see over here is that these cancel out. And then we're going to have x raised to the power of 4. Upper limit is 2 and lower limit is 1. Okay. And now we're going to be using this form over here. F of b minus f of a. Can you see that this is actually represented as our capital letter f of x now? Because we found the integral already. So that is our capital letter f of x. So that means we're just going to sub in a and b. But we must do it in this way, in this over here, right? So we're going to have this over here, which is x to the power 4, but we're going to first do the upper limit, which you can see over here. Remember that the upper limit is actually just our b value, and the lower limit is actually our a value, right? And let's just observe this over here, f of b minus f of a. That's what we're going to do over here. So f of b is just going to be, x is going to be replaced with the b value, which is 2 raised to the power of 4, minus, and then this is going to be our a value, which is going to be replaced, which is 1. So it's 1 to the power of 4. And therefore, 2 to the power of 4 is equal to 16 minus 1, which is just going to be equal to 15. And that is our answer for this definite integral. So let's do another one for practice. Okay, so for this next one, what I'm going to be doing is I'm going to show you how to do the next step here, right? So what do we have? We have a rational function over here, and we also have a radical, right? A third. So first we need to break it down so that we can actually integrate, right? So we can break it down like this. It's going to be the integral where the upper limit is 9 and the lower limit is 4. And then we're going to have 1 over root x with respect to dx, right? Because we're taking the dx down. Okay, now it looks like a proper integral. But we can actually write this 1 over x as 1 over x to the half, right? Because the third can be written as a half, as the exponent. But we can also rewrite this entire thing over here. Because it's in the denominator, we can write it as a negative exponent. So it'll look something like this. It'll be x to the power of negative a half. And there we go. So now we can take the integral. And we can say this is equal to. And then we're going to do the following. We're going to have our square brackets. And then we're going to have x raised to the power of. Or no, sorry, we're taking the integral over here, right? So it's going to be x raised to the power of negative 1 over 2 plus 1 divided by negative 1 over 2 plus 1. Close the bracket, we have an upper limit and lower limit. And then this is just going to be equal to, I'm just going to do the equal signs over here. Okay, so we're going to simplify further. We're going to have the bracket, it's going to be x raised to the power of a positive 1 over 2, because negative 1 over 2 plus 1 is just positive 1 over 2. Divided by the same thing, 1 over 2. Then it's going to be 9 and 4. And then, sorry, we can simplify it like this. It's going to be tip and times, so it's going to be x raised to the half multiplied by 2. So it's going to be 2x raised to the half. Okay, and this is going to be 9 and 4. But we know that we can, but now we can actually simplify, right? Or we can make this easier to read. This x to the power of a half, well, that can actually be written as x square root of x, like that. There we go. Okay, now that we've done that, we can just take in the, we can write it in this format over here. It'll be, so I'm going to start here. 2 multiplied by the square root of the upper limit, which is 9, minus 2 multiplied by the square root of the lower limit, which is 4. And then this is just going to give us an answer of 2 multiplied by a square root of 9. 2 multiplied by the square root of 9. Square root of 9 is 3. 2 times 3 is 6. And then this is minus. This is 2 times square root of 4. Square root of 4 is 2. 2 times 2 is equal to 4. So therefore this answer is going to be equal to 2. And that is the answer of this definite integral. Let's do another one. Alright, so now we have a polynomial, right? So once again, we have the integral of x cubed minus 6x squared plus 4x minus 8 with respect to x. So we can see that obviously we have to integrate this over here. Remember, it's between the integral symbol and the dx, meaning that that's where we have to integrate, right? So this is going to be equal to, now we need, while we can write it like this, 2 and negative 2, which is x third with respect to dx. Well, we can actually just separate it, and then we can obviously write minus, and then this is going to be 2, negative 2, 6x squared, or you can write it as minus 6 over here. Let me just keep 6 over here. You can write it out like this, or you can just do it the quicker way. If your lecturer does say that you have to do it like this, and then obviously you have to keep going onwards by linearizing the integral, then I think you have to stick with his or her method. But I would take the integral in like this, so that we can just integrate all of them by one without doing this step over here. So this is how I would do it, right? So we're going to skip that step of taking the integral into everything, or all of the terms, and we're just going to write it like this. So we're going to have this here. The integral, okay, so I'm just going to, okay, never mind, I'm just going to do it one by one, it's fine. X raised to the power of 3 divided by, it's plus 1, sorry, over here. From now on, what I'm going to do is I'm going to instantly add this by 1. So I'm not going to be showing the steps anymore. 3 plus 1 is just 4. And then obviously the denominator will be the same as the exponent, right? So that's what we need to get used to. As we go on with integrals, we will find ways to actually make it as quick as possible, right? We would like to speed run things. And that is our inner mathematicians coming out of us, right? It's basically just means that we are lazy people. See? But yeah, it's still smart at the same time. Okay, so this is minus, and then we have 6x raised to the power of 3, because this 2 is added by 1, divided by the same thing, which is 3. Plus, this is going to be 4x raised to the 2 divided by 2. Okay, minus 8 multiplied by x, because this dx goes into the 8, or the x will be multiplied by 8. We know that the integral of a constant is just the constant multiplied by whatever you have respect to. Okay, and then we close this over here, and we have the upper limit and the lower limit. Hey, look at that. Easy as pie. Now we can make this a little bit more simple for ourselves. We can, or I guess you don't really have to do that. We can actually just plug the stuff in now, right? But you know what? It's fine. I was gonna say, like, you can write the fraction, write it fraction by fraction. I guess let's just do that for the practice. We know that this is actually 1 over 4 multiplied by x to the 4th, so which means we can actually write this as 1 over 4 times x to the 4th, like that, minus, and then we have 6 over 3 times x to the 3rd, where 6 over 3 is just equal to 2. Plus, we have 4 over 2 times x to the, so it's going to be 4 over 2 times x to the x squared. 4 over 2 is equal to 2. Minus 8x, and there we go. That's what we have. And the upper and lower limit. And then this is just going to be equal to, can you see how simple things are now? It's better if we just write it like this than just leave it like this, because we can just simplify things clearly. Okay, and I like to write my my x's out of the fraction because then it is in polynomial form and it's easier to do calculations without the calculator. Okay, cool. So then we're just going to substitute, right? The first one is going to be f of b. So we're going to plug in the b, or the upper limit first. So it's going to be 1 over 4 multiplied by positive 2 raised to the power of 4 minus 2 into 2 raised to the power of 3 plus 2 into 2 raised to the power of 2 minus 8 into 2, positive 2. Okay. And now we're going to minus. I'm going to do the minus over here. I'm going to start the other part here because obviously the space. What I'm going to do over here is, because, remember, if we say minus, we're going to put the bracket. So let me keep the bracket for now, because we are doing this thing like this. So it's going to be a fourth multiplied by negative 2. Remember, it's the lower limit now. Raised to the power of 4 minus 2 into negative 2 raised to the power of 3 plus 2 to the power of 2 times negative 2 raised to the power of 2 minus 8 times negative 2. There we go. So now we've just done this, all of this over here, and the brackets were definitely important because remember, this entire bracket here is just capital F of B. I mean F of A, sorry. So now because of that, this negative will go into this entire bracket. So we're just going to change the signs of everything then. So it's just going to be 1 over 4 times 2 to the power of 4 minus 2 times 2 raised to the power of 3 plus 2 times 2 raised to the power of 2 minus 8 times 2. And then obviously we're just going to take the negative in. All of these signs are just going to change to its opposite. This is positive over here. So this will be negative fourth multiplied by negative 2 raised to the power of 4 plus 2 times negative 2 raised to the power of 3 minus 2 times negative 2 raised to the power of 2 plus 8 times negative 2 over here. Okay. So it's written like that. Cool stuff. Now, what do we notice here? Now, this is the part where we need to be confident with our mathematics, right? This is the same as this, right? Because you can see that the exponent is an even number, right? It's an even integer. Therefore, meaning that this answer would be the same answer, or this answer over here would be the same as this, meaning that these will actually just cancel out because it's going to be this minus that, right? That's why I wrote it like this. The next one over here is an odd exponent, so which means we're going to keep this. Nothing's going to cancel out because this is a negative and nothing's going to cancel out. This is only to our advantage because we have the same number. Okay, let's look at the other one, right? This one compared to this over here. It's a even exponent, therefore this answer inside will be the positive 4, and this will also be positive 4 if you take the exponent, so therefore these will cancel out, and then therefore these ones will be different because there's just an odd exponent. Okay, so then we can write it like this. What we have left is negative 2 multiplied by 2 raised to the power of 3 minus 8 multiplied by 2 plus 2 multiplied by negative 2 raised to the power of 3 plus 8 into negative 2. Okay, and then we can simplify this further. Negative 2 multiplied by 2 to the power of 3, 2 to the power of 3 is equal to 8, so that's negative 2 times 8, which is negative 16. Negative 8 times 2 is negative 16, plus 2 to the, okay, so 2 times negative 2 to the power of 3, negative 2 to the power of 3 is just equal to negative 8, negative 8 times 2 is equal to negative 16. And then 8 times negative 2 is equal to negative 16. So therefore the answer here is negative 64. And that is the answer, negative 64. Let's move on to another one, but we're going to just make it a little bit more spicy. Okay, so this is the second last integral that I'm going to be doing for this video. Now what do we notice here? What we are going to be doing over here is we need to rewrite it like this, right? So what do we notice here? This is the integral, upper limit and lower limit over here. And then we have, if we break this down, we can actually write it as 1 over 5 multiplied by x to the power of 4, right? Where, because this is a constant, we can actually just take this, also this is with respect to dx. Because this is a constant over here, we can take this outside of the integral, meaning it will be 1 over 5 multiplied by the integral of where 5 and 0 are the upper and lower limits respectively of x to the power of 4 with respect to dx. Can you see how we made it a little bit easier to read now? Okay. So now we're going to take the integral. So we're basically taking the integral from everywhere like this, right? And the 1 over 5 is just left outside. So we're only going to deal with the 1 over 5 when we get to our final answer. So we're going to take the integral. 1 over 5 is outside of the bracket. And then inside of the bracket, we're taking the integral of x to the power of 4. So it's going to look like this, right? We're going to get an answer of x to the power of 5 divided by 5. That is what we're going to get. That's the integral of x to the power of 4 with respect to x. Upper limit and lower limit as well. And then we can just, leave it like that. Okay. Over here, 1 over 5 multiplied by. So what I'm going to do now is I'm going to take the limits in now. The upper limit first, it's going to look like this. So I'm just going to keep the square bracket like this, right? Or just, I guess I'll do this. Okay. So what do we have here? It's going to be x to the power of 5 divided by 5. We're going to take the upper limit in first, so it's going to be 5 to the power of 5 divided by 5, right? And this is going to be minus the one of the lower limit, which is going to be 0 to the power of 5 divided by 5. Okay, so that's what it's going to look like. And before we take the 5 in, what I want to do is this. 1 over 5 bracket. Then we're going to have 5 to the power of 5 divided by 5 to the power of 1. We know that this can also be written as 5 to the power of 5 minus 1, which is equal to 5 to the power of 4, which is equal to 625. Okay. And now what we can see over here is that, but we're gonna keep it like this, and I'm gonna show you why. We have 5 to the power of 4 now, minus 0 to the power of 5 is just equal to 0, so therefore this whole thing will be 0. Therefore this will give us the following, right? We have 1 over 5 multiplied by 5 to the power of 4, which we can actually write as 5 to the power of 4 divided by 5 to the power of 1, which this will give us 5 to the power of 4 minus 1, which is equal to 5 to the power of 3, which is equal to 125. And that is our answer for this one over here. So this one is it's not really that bad. It's just like you need to know your exponent laws to make things easier for yourself. You note how I didn't even have to use a calculator. Otherwise, you would have to put in 5 to the power of 5, which I believe is 3,125 from my knowledge. If I'm wrong, then I apologize. But yeah. But otherwise, if you use your exponent laws, look how easy it becomes. You see? Okay, let's move on to the last example. Okay, so here's the last one. What do we see here? We have the integral with the upper limit being e, which is Euler's number, and 1, which is just 1. So we need to rewrite this integral like this, right? We can rewrite it like this, the integral upper limit, lower limit of 1 over x with respect to x. There we go. Now it's easier to deal with. And what do we know about the integral of 1 over x with respect to dx? That is just equal to the natural log of absolute value of x. So that's what we're going to be writing here. Previous video covered it in more detail of why we have the absolute value. You can check it out because in the beginning of the video I did put the card in. Okay, so we have the integral over here. We're going to take the integral now. Okay, so first of all we need to write our bracket here. This is going to be the ln, the natural log of as absolute value of x, like that, right? Then we close our bracket there, upper limit and lower limit. So now we're going to write it like this. It's going to be ln of the upper limit, which is e, minus ln of the lower limit, which is 1. And then this is just going to give us an answer of ln of e is just equal to 1 due to our logarithmic laws, minus ln of 1 is just equal to 0 according to our graph. Okay, and then 1 minus 0 is just equal to 1, and that is the answer. So it wasn't really such a difficult one. I just wanted to keep the natural log for last because sometimes it actually does catch you out. Whenever you have like x in the denominator, you would most likely write it as x to the power of negative 1. But when we're dealing with integrals, I never recommend ever writing x to the denominator as x into x to the power of negative 1. Otherwise, you'll get x to the power of negative 1 plus 1, which is x to the power of 0. And then there's going to also be issues because you're going to have 0 in the denominator as well. It'll look like this. No, sorry, -1. But it'll look like this. And you don't want that because 0 is in the denominator. Okay? So please keep that in mind. And that was the answer for our last integral.